This one's a cracker, isn't it? So I've already started with the binomial expansion because it's in your formula sheet. You don't need to remember it, you just need to be able to apply it. So we want the coefficient of x to the p on one side, and that will equal the coefficient of x to the p plus 2 on the other. So we're just balancing sides. So let's look at the x to the p side. It's going to be 100 cp. I've got a root 1953. Now that's going to be to the 100 minus p, because the root 741x has to be to the p. So these two need to add to get 100. So that's how you get the binomial expansion pattern working. And we definitely want the x to the p. So that's how we know that term. In saying that, it's the coefficient of x. So this x doesn't want to be there. We just want to cancel that out. It's just root 741 to the p. And we're going to do that to the same thing to the other side, but it's going to be to the p plus 2. So it's going to be 100c p plus 2 root 1953. These are tragic numbers, aren't they? That's going to be 100 minus p plus 2, so it's minus 2 because it's in front of a bracket, and root 741 to the p plus 2. Oh my gosh, that is looking really gnarly. So let's just get rid of all of that yuckiness and just neaten that up a little bit. Okay, that is way not looking easy, is it? Anyway, let's just see how we go. So 100 CP, so 100 factorial on that was easy enough. Let's split that up. So it's going to be root 1953 to the 100 and root 1953 to the p, but it's minus p, so it's going to be underneath, and root 741 to the p equals 100 factorial on factorial p plus 2 factorial. It's 100 minus 2, that's going to be 1953 to the 98 minus p, and we've got that's a root on 1953 to the p underneath again. And the 741, that's going to be root 741 to the p and root 741 squared. Oh my gosh, I'm out of room. That is craziness. That is a dislike on this video right there. Okay. I don't know whether you can see it. I'm going to do it in red. We've got a 100 factorial on both sides, so they're going to cancel out. I've got a root 195.3 to the p on both sides. They're both on the underneath. And we've got a root 741 to the p. They just cancel out. Super duper. That's about it for this at this point, but that tidies it up just a little bit. So root 1953 to the power 100. Loving that. 100 minus p factorial. So this is strategy in your exam, is to neaten things up so your eyes can see what's going on. Root 1953 to the 98. This thing here is in the numerator, remember, I just couldn't fit it in, and it's root 741 squared, which is just 741 on, there's a p plus 2 factorial, and this other one is 100 minus 2. Whew, okay, there we go. See that root 1953 to 100 on the left? Wouldn't it be nice if that was 100? Then that would just cancel out. So what I'm going to do is I'm going to multiply the right-hand side by 195, the root squared, which means I've got to multiply this other side by. So together, that's root 1953 to the 100. So that cancels with that. And this thing here, clearly the square and the square root cancels each other out. And we've got 1953 on. Yes, I could look at the numerator at the same time, but I think it would just be way too busy. You can see how each step, the harder it is, the slower I want to go, I think. And you can see that numerator's just tied it up really nicely. Okay. Clearly, I'm going to need to do something with this 100 minus p. And I'm going to want to get as close as I can to 98 minus p. So that's factorial, isn't it? Sorry. That's factorial. Drop the exclamation mark. So it's going to be 100 minus p. What's 1 less than that? And what's 1 less than that? Factorial. And then there's a p factorial. So I'm happy with this 98 minus p factorial because it's going to cancel over here, which is nice. But now I'm wanting to expand that p plus 2 factorial. So it's p plus 2. What's 1 less than that? And 1 less than that. Oh my gosh, let's cancel our little hearts out. So the 98 minus p factorial cancels, and the p factorial cancels, and we end up with 1953 on equals okay. So up the top, I didn't quite put there, but this is definitely tech active, clearly with those numbers. But you can't use nsolve. I know I can get some nsolve to work with a factorial, but it's quite simple. And I just could not get that to work. But guess what that is? That's just a nice equation. So I'm going to solve in that bad boy. And you're going to get P is 37, or some really weird sort of fraction, minus 327 on 2. So that's a decimal. You can't raise something to a decimal, and it's also a negative, so that you're just yucky. So P is 37. That is an absolute cracker of a question. Mostly done without a calculator. And yes, you can't do that without a calculator. Okay, hope you enjoyed that one.